So a dot diagram is a representation of the valence electrons around the center of the atom. We will use a chemical symbol representing the atom, and we're going to put the valence electrons as dots around it. So the group number is the number of valence electrons. So the first thing you do is find the element, look up the group number, and then you're going to put one dot to represent a valence electron on each side. So you put them out one at a time. One on the top, one on the left, one on the bottom, one on the right. Although it doesn't particularly matter which side you start on and which direction you go, put one dot on each side. Once you have one dot on all four sides, if you have more than 4 valence electrons, then you can continue having 2 dots on one side. So for instance, if I wanted to draw the dot diagram for sodium, so sodium is in group 1, so it has 1 valence electron. So I put a dot. It doesn't matter whether I put it top, bottom, left, right, there's just 1 dot. And then if I wanted to do sodium, let's not do sodium, let's do sulfur, which is in group 6. So it has 6 valence electrons. We put sulfur, again, 1, 2, 3, 4, 5, 6. Once again, it doesn't matter which side you start on and which direction you go, but you will end up with the different variations. But what's important is that I see that I have 2 sides that have 2 dots and the other 2 sides have just 1 dot. So these would be the proper dot diagrams. And we can see here some examples representative. So again, what happens when we make ions? Remember, metals lose their valence electrons when they form ions, and nonmetals gain. So I have to look back at the periodic table now that I know what they are, and I have to figure out not just its group number, but which side of the staircase it's on. So it's a metal because it's on the left of the staircase. So calcium has 2, it will lose 2. So note that now they're missing. I erase them, I move them somewhere else, and they're gone. And in its place, I have a charge. Technically speaking, we usually put a bracket around it and then put the charge. But it definitely has to have a charge shown. And then we, in the case of fluorine, it's a nonmetal because it's to the right of the staircase. And so nonmetals gain enough valence electrons until they have a full valence shell, which is 8. Notice 1, 2, 3, 4, 5, 6, 7. It has 7. And you can see where there's like a spot empty for it right here. So it would have to gain it from a metal or from something, and it's going to add in here. So when I'm done, I should have 8 dots around it and whatever charge. In this case, it gained 1, so it has a charge of -1. Again, you could put it in brackets and then put the charge outside the brackets. So we see how the ions look. It's only a little bit of a so it's just a step up to determine how to draw a dot diagram for an ionic compound. The idea is we're kind of going to put them together in such a way that we see where the electrons went from to. They'll go from the metals to the nonmetals, and when I'm done, all the charges need to cancel out and be 0. So I may need more than one. All right, so if I take a sodium, we just drew its dot diagram on the last page, and I take a sulfur, I would only put, one at a time on each side, but I was just trying to redraw it from the last page. Okay, so I can see this is a metal, and they lose. This is a nonmetal, and they gain. So it's going to lose it, and it's going to go over to the nonmetal. Note that this is good, right? Sodium now has a plus charge. It's lost its electron. It has no electrons. That's what we want for metals. But sulfur is not good yet. I still have a missing electron. It now has 7, but it still needs 1 more. The only thing that can supply it with another is another metal. So we'll have to take another one. Here, maybe I'll do it in purple. And again, now we see that this one would be sodium with a plus charge, and its electrons would be here, right? So now sulfur has a full shell. And so now I can put a bracket around it. It gained 2. Remember, this one had come from the other one. So this would be a -2 or 2 minus. So this would be the dot structure for sodium sulfide. And the chemical formula, I count up how many I have. I have 2 sodium, so I'd put a subscript of 2 and 1 sulfur. So that would be the way I would write the chemical formula. I could kind of figure it out. And again, this comes from the basic idea that sulfur needs to gain 2 to get to 8, but sodium only has 1 to give away. And therefore, the quantities need to adjust to make it work out.